Okay, I'm going to walk you through two more examples of some stoichiometry just to kind of help you guys if you need a little more help with looking at how to do these gram to gram calculations. So remember, the reason we're using grams is that's the way it's easily measured, right? You know, I could tell anybody in the room to go measure 10 grams of, aluminum or 20 grams of copper, and you could go back to a scale right away and measure it. But it's not how we compare chemicals, right? So remember, on a balanced chemical reaction, these are the mole ratios that the chemicals react. They're not the gram ratios, okay? So the reason why we're doing this is you can only compare chemicals through moles because chemistry happens on that atomic level, right, that atom-to-atom basis. But you don't count atoms. So you can measure masses and then you can convert to moles. Okay, so let's do two practice problems here. If you're still wanting a little more help with this. So how many grams of sodium phosphate are required to make 225 grams of lead 2 phosphate based on the following chemical reaction? Okay, so here's what I want to find out. Okay, if I want to make 225 grams of this compound, how many grams of this do I need to start with? Okay. So let's start. All right, we always start with what we're given. In this case, I'm given 225 grams of lead phosphate. So I want 225 grams of lead 2 phosphate. And the first thing I want to do is I want to get rid of grams, okay, because I've got to convert to another chemical, correct? So I'm going from lead phosphate back here to sodium phosphate. And the only way to convert from one chemical to another chemical is through moles. So the first step here is, how do I get rid of the grams and how do I get to moles? Well, this is just a molar mass conversion. I have grams of lead phosphate, so I want grams on the bottom. I want to go to moles of lead phosphate. Well, from the periodic table, I can find the masses of all these compounds and find out how much 1 mole weighs. So we have 207 grams due to lead, and I have 3 leads, so times 3. Plus, this 2 distributes in here to the oxygen and the phosphorus, so 2 times 30, I think phosphorus is what, 31? Yep, 31. Plus 8 times 16. Okay, and when we add all those up, real quick, we can find the molar mass of lead 2 phosphate. And what we get is a mass of 811 grams. So this is moles of PB. 3 PO4 2. Okay, so my grams are going to cancel out, but now I'm in moles of lead phosphate, lead 2 phosphate, which is good because as soon as we get moles, then we can convert from moles of one chemical to moles of another chemical. And remember, we have this ratio from our balanced chemical reaction. I know that I need 2 moles of lead or sodium phosphate for every 1 mole of lead 2 phosphate. So that's going to be my next thing. So first, you're going to convert to grams, or to moles, sorry. And now we're going to convert to a different chemical. Okay, so my moles of lead 2 phosphate are going to go down here in the bottom because I want it to cancel out. And I want to go to sodium phosphate, so that's going to go up here, moles of Na3PO4. And how do I convert from one chemical to another chemical? From my balanced chemical reaction. So I know that 2 moles of sodium phosphate per every 1 mole of lead 2 phosphate. My moles of lead 2 phosphate cancel out, and now I'm in moles of sodium phosphate, right? That's what my units say. This is kind of getting messy here. So convert to moles first, then we convert chemicals. So and then the last thing is, now that I'm in sodium phosphate, well, I can convert back to grams. So I want 1 mole of sodium phosphate at the bottom. And I know I want to go find the molar mass of sodium phosphate. So I look on the periodic table. The molar mass of sodium is 23 plus 31 plus 4 times 16. It gives me a molar mass of gives me a molar mass of 164 grams per mole. So 164 grams per mole. So my moles are going to cancel, and then I'm left with grams. Okay? So this is always the path that we're going to want to do. So now our next step with this is just to do the arithmetic. I'm going to multiply across the top and divide by the product of the bottom. Okay, so 225 times 2 times 164 divided by 811. And what I come to find out is I would need 90.998, or we'll go ahead and round that to 91 grams of sodium phosphate. Okay, let's do one more practice problem here. But again, here's our step. Convert to moles. Why? Because moles are the only way I can compare chemicals. Convert from one chemical to another chemical. Why? How? Through a balanced chemical reaction. Final, convert back to grams because I want the answer in grams. So let's take a look at this last problem right here. How many grams of oxygen are needed to combust 100 grams of methane? Okay. Now, you can convert between moles of any chemicals on any side of the reaction. In this case, for every 1 mole of methane, I need 2 moles of oxygen. I don't always have to go to the products. So let's go ahead and set up what we have. We have 100 grams of methane, which is CH4. Okay, first step is I can't convert from grams to grams. I've got to go to moles. So I know that there are 16 grams of methane per every 1 mole. Got that from the periodic table. Molar mass is 12 plus 4 times 1. 16. So now I'm in moles of methane, CH4. Maybe I should put that there. Okay, but now I can convert to another chemical. So I want moles of methane down here on the bottom, CH4, and I want to go to moles of O2. Okay, and here is where we're always going to go to a balanced chemical reaction. So whenever I have moles, when I'm going from moles of one chemical to another chemical, that's going to be from my coefficients of my balanced chemical reaction. So I look, hey, I know there's a 1 right here. So per every 1 mole of methane, I need what? I need 2 moles of oxygen. My moles of methane cancel. So now I'm in moles of oxygen, which is good because now that I'm in moles of oxygen, I can convert to grams of oxygen. So I know that in 1 mole of oxygen, it's O2, right? There's this 2 right here. So it's going to be 16 times 2, or 32 grams. And again, where did I get that value from? I got that from the periodic table. So my moles of oxygen are going to cancel out. And I'm just going to multiply now. 100 times 2 times 32, divide it by 16 times 1 times 1, so just divide by 16. And what I come to find out is that I would need 400 grams of O2. Okay, so hopefully if those 2 problems help you a little bit more as you're working on your homework today. Hope you guys have a great day.